Hey y'all, today's lesson, hold on, let me move this. Okay, today we're gonna go over changes in dimension, and we're gonna talk about both surface area and volume. We did a little bit of this when we talked about what a scale factor, when we talked about similar figures and what a scale factor does to the perimeter and the area. And we're going to extend that knowledge to now what does a scale factor do to the surface area and the volume. And so for the first example we have, we're going to kind of do like a little investigation. And, well, no, trying to figure out how to make this camera so I'm going to move me. There. Okay, so example 1, the cubes below are similar. The dimensions are doubled. What happens to the surface area of the cubes? So we've been talking about volume and surface area. Now we're going to talk about what happens when you change the dimensions. Now the dimensions are doubled. So that means my scale factor is 2 because I've doubled the dimensions. What happens to the surface area? And I picked cubes because those are easy to calculate the surface area because all 6 surfaces are the same. So for this one, to find the surface area, we could just find the area of one surface. So I'm just going to use this front square. And the area of the square is 4 by 4, which is 16. And then there are 6 faces. So 16 times 6 is, and I'm just going to type that on my calculator, 16 times 6 is 96 inches squared. So the surface area is 96 inches squared. Now we are going to double the dimensions and we're going to find the surface area of this bigger cube. Now notice I've doubled all of them, 4 to 8 all over, length, width, and height. So again, I'm going to find the surface area. I'm going to shade in this front square. The area of that front square is 8 by 8, which is 64. And then I'm going to multiply that by 6 because there are 6 faces. And I get 384 inches squared. So how are the two surface areas related? What did the dimensions do between the surface area of a smaller cube when the dimensions are doubled? Now, you might think, oh, it doubled. 96 times 2 is only 192. So it didn't double. So it quadrupled. Let's see, 96 times 4 is 384. So that's what happened, is it was times 4 bigger. And if you remember when we did perimeter and area, what happens if you're trying to find the area of a shape and you have a scale factor? It's the scale factor squared. And the reason is, I can show you real quick, the reason is because when we find the area of something, we do 4 times 4, right? 4 times 4. Now over here, we doubled the 4. So we did 2 times 4, because 2 times 4 is 8, times 2 times 4 again. Notice we're doubling the 4. 2 times 4 is 8. 2 times 4 is 8. And I could rewrite it 2 squared times 4 times 4. And that's where the scale factor squared comes from, because I multiplied the length by 2 and the width by 2 to get my new dimensions, 8 times 8. So for the key concepts for this lesson, and then I'm going to show you a volume example. The key concepts: surface area of similar solids. Now, first of all, you have to hear me. The shapes have to be similar. The shapes must be similar. So you might want to underline or highlight the word similar. The shapes must be the shapes must be similar. And if you're talking about surface area, then if you have 2 similar shapes, we'll just, 2 similar shapes, the surface area uses the scale factor squared. Scale factor squared. I feel like I don't know if you can see kind of the ink on my pen. I'm going to change because it feels like it's going to kind of leak on me a little bit. All right, I'll try a different one. So again, if it's surface area, very similar to area we already did, you take the scale factor and you square it. And that's an example right here. The scale factor was 2, so we did 2 squared. And then that was 96 times 4. Okay? Now, the key concepts with volume. Volume is a little bit different. If you have two similar shapes, now again, they have to be similar. The volume uses the scale factor cubed. And that should make sense. Area is squared, volume is cubed, scale factor cubed. And let's do an example that goes over that. I'm going to move my box now back to the top. Kind of like a tickle in my throat for some reason. The cubes below are similar and the ratio of their corresponding sides is 1 to 2. What happens to the volume of the cubes? Now, do you see we use the word ratio from 1 to 2? 1 to 2. That means this is a size with, like 1 part, and this is double, 1 to 2. 2 is double 1. So that means the scale factor is 2 because it's getting bigger by 2. You can always look at the ratio, and the scale factor will be the ratio upside down, or like opposite. So let's find the volume of the small cube, and it would be 4 times 4 times 4, which is 64 inches cubed. And then the volume of the bigger cube would be 8 cubed, 8 times 8 times 8, which is 512 inches cubed. And now we want to find the relationship between the volume of the big cube and the volume of the smaller cube. So I'm going to divide 512 divided by 64, and I get 8. So how do 8 and 2 relate? How do they relate? Well, 2 to the third power is 8. And that's what I mean by scale factor cubed. Whatever the scale factor is, you could cube it, and then that is going to be how many times bigger or how many times smaller the new shape is. These two shapes are both getting bigger, but I'm going to show you ones that have fractions in them too. All right, example 3. The surface area of a rectangular prism is 78 square centimeters. So we've already been given surface area is 78 square centimeters. What is the surface area of a similar prism with dimensions that are 3 times as the dimensions of the original prism? So I know my scale factor is 3. That's all the information they gave us. They didn't tell us what any of the dimensions were. They didn't draw us a picture or give us a shape. All we know is we have 2 similar prisms, and I know that one of them has a surface area of 78 centimeters squared and a scale factor of 3. So if you forget, go back and look at your key concepts. But since we're talking about surface area, that means we're going to use the scale factor squared. So 3 squared is 9. And then what we're going to do is we're going to just do 78 times 9. And we get 702 centimeters squared. And that is the surface area of the new, bigger prism with dimensions that are 3 times as bigger. And what we did was we took the scale factor and we squared it because it was surface area. Scale factor squared. All right, look at the back. Let me go to the top. Let me move that again. Whoa, whoops, can you see me? I have no idea how much time we have, so let me just check. Okay, 8 minutes. Uh-oh. I don't know how to get... Oh, here it is. Okay, sorry. Example 4. A triangular prism has a volume of 432 cubic yards. All right, so this is a volume question. If the dimensions of the prism are reduced, say reduced, by 1/3, so a scale factor is 1/3. It doesn't say ratio, it says it's reduced to 1/3 the original dimensions. What is the volume of the new prism? So again, if it's volume, you can go back and look. If it's volume, we use the scale factor cubed. So 1/3 cubed is 1/27. And now you have 2 choices. You could say 432 times 1/27 or 432 divided by 27. It's the same mathematically. It's the same because you could put that over 1. Or you could just go ahead and divide 432 divided by 27. So that means the new volume, the volume of the new prism will be 16 cubic yards. 16 cubic yards. And again, I use the scale factor cubed because this was volume. Number 5, the surface area of a triangular prism. Sorry, I got distracted by that little. The surface area of a triangular prism is 34 square inches. What is the surface area? Okay, surface area, 34 squared inches. What is the surface area of a similar prism with dimensions that are 2 times as great as the dimensions of the original? So again, my scale factor is 2. And because it's a surface area, I'm going to do 2 squared, which is 4. It's all about the scale factor. 34 times 4 is 136. What are we talking about? Inches squared. 136 inches squared. Okay. So number 6, a rectangular prism has a volume of 512 cubic centimeters. And it's important that you know if you're doing volume or if you're doing surface area. What is the volume of a rectangular prism with dimensions 1/4 of the original? So my scale factor is 1/4. And since we're talking about volume, I know that means 1/4 cubed, which is 1/64. And like I said just above, at number 4, you have 2 choices. You could say 512 times 1/64 or 512 divided by 64. It's up to you. It doesn't matter to me which one you choose because mathematically they mean the same thing. You're multiplying by the scale factor cubed, and multiplying by this fraction is the same thing as dividing. So I'm just going to divide it. 512 divided by 64, which means the new volume is 8, what are we talking about? 8 centimeters cubed. All right, so that is the new volume. All right, so you have 2 U-tries. I would like for you to try them, pause, and then press play when you're ready to see the answer. I will share the answer with you. Okay. A cylinder has a volume of 432 cubic meters. I feel like we just used 432. Oh yeah, right here, 432. What is the volume of a cylinder with dimensions 1/3 the original? So again, my scale factor is 1/3, and since I'm dealing with volume, I'm going to cube it. And I just like to divide. 432 divided by 27. I guess I could just look because we just did this one. 16 meters cubed. That is the volume of the new cylinder that is 1/3 the size of the other cylinder. All right, last U-try. The world's largest box of raisins has a surface area of 352. I feel like we used 352 also. No, maybe not. So surface area is 352 feet squared. If the dimensions of a similar box are smaller by a scale factor of 1/48. Oh, wow. So the scale factor is 1/48. That means, that this big, the largest box of raisins is going to be tiny, tiny. If the similar box of dimensions is a large box by a scale factor of 1/48, what is the surface area? So again, this is surface area, so I'm going to do 1/48 squared. And I don't know what 48 squared is. So 48 squared is 2,304. And the 1 just is 1 squared is 1. So 352 divided by 2,304. 352 divided by 2,304. And we get a decimal, 0.15, or let me remind you, change it to a fraction. So you press math, arrow frac, and we get 11 over 72 feet squared. Oh, sorry. All right, so this may have been fast. I hope you were able to stick with it, and we will use this in class and practice more.